Greetings, this is M squared, and what we're going to do today is we're going to take one linear system and we're going to solve it all three ways. We're going to graph it, we're going to use substitution, and we're going to use addition and subtraction. I just want to show you that it doesn't matter which way you use. You can take any linear system and still solve it using any method. So let's start with substitution. This variable is all alone, the y equals 3x plus 2. So what I'm going to do is rewrite this equation without the y, and I'm going to put 3x plus 2 in for y. So there's my y minus x equals 4. And y, again, is 3x plus 2, or so it says right there. So now I'm going to simplify. There wasn't a coefficient in front of this y, so I simply this parenthesis was there just to show you that that was y, but I don't need to multiply or distribute. So I get 3x minus x plus 2 equals 4. So 2x plus 2 equals 4. 2x equals, when I subtract 2 to both sides, I get 2x equals 2, so x must equal 1. Then I substitute back. I go to the original equation and I put 1 back in, so I get 3 times 1 plus 2. 3 times 1 plus 2, that's 3 plus 2, which is 5. So now I know that x equals 1 and y equals 5. So over here in the graphing method, let me make our little xy. And this one's all set up to graph. It's in slope-intercept form already. The slope is 3, the y-intercept is 2. So I go up on my y-axis 2, and then I go up 3 over 1, and I can go this way as well, and I connect the dots. This one I need to get into slope-intercept form, so I add x to both sides. So I would get y equals x plus 4. So my y-intercept is 4, and my slope is 1. And here's my point of intersection, which is 1, 1, 2, 3, 4, 5. And then I can check, and that's exactly what I got over here. I got a 1, 5, which is important because that was the answer. So now addition and subtraction. Remember, the key to addition and subtraction is that you have all the x's lined up, all the y's lined up, and all the constants lined up. So this one already has a y minus x, so we'll just move the x over on this first one. If I minus 3x from both sides, I get negative 3x plus y equals 2. And then I'm just going to have to switch these. I don't change the signs if I'm just switching the order. So I switch the order over there. And then I combine. I want to have the same sign, so I'm going to multiply this all by negative 1. Or you could subtract as well. But I like to add, so I usually do that. So I'm going to rewrite that first one, and then I'm going to change all the signs on the second one. And when I do that, I get a negative 2x equals, did I forget to change the sign on the 4? I did, negative 2. So x equals negative 1 when I divide both sides by negative 2. And then I plug that 1 back into the original equation, so I get negative 3x, except instead of x, I'm going to put a negative 1. And instead of y, I should put what? Oh, never mind. We're solving for y, aren't we? Sorry about that. So negative 3 times 1, negative 1, is 3. So I add, I'm sorry, that's a positive 3. Did I get negative 3 times, bear with me when I'm going through this. I got a negative 1, but I was supposed to get a positive 1. That's what's messing me up. Okay, correction made. A negative 2 divided by a negative 2 is indeed a positive 1, and I should have known that from over here because that was a positive 1. Okay, so now we're good. This is a negative 3. So when I add 3 to both sides, I get y equals 5. And you might make little mistakes like that as well, and you might not have figured it out. I mean, while I was doing it, you probably figured it out. But if you're actually doing it yourself and you make a mistake, you'll notice it when you get ready to check. That's why it's so important to check. Because it's just little signs and things that usually, the majority of kids make a sign mistake, especially when they're adding or subtracting negative numbers. So make sure you check. You can use your calculator if you need to, but I just wanted to show you that, you know, it doesn't really matter which way you pick. You can do it either way. And a lot of times when you're practicing that these methods, you get one that you really like a lot more. I would say this is the one that kids tend to gravitate towards the most. I'm not sure why. This is the least favorite for some reason, but it's kind of one of my favorites. So have fun trying to figure out which method you want to use. And this is M Squared signing out.